Hello and welcome to all our viewers and subscribers. Thank you for joining us today in the 10th lecture of the Ant Biology webinar series presented to you by the Translational Outcomes Research Group of the Department of Zoology, University of Calcutta. I am Shinjini. I'll be moderating today's session. As many of you know, we have been hosting fortnightly lectures over the past 2.5 months to keep us stimulated in these dire times, with Saturday lectures on topics related to other disciplines and Sunday lectures on different topics of life sciences. Before we begin, I would like to remind you that you can post your questions in the YouTube chat box and we shall moderate them at the end of the lecture. To receive participation certificates, please fill the feedback link that is provided at the end of the session within the stipulated time, and the link will not be sent by email. So unfortunately, our convener today, Professor Inare Banerjee, is unable to join us at this moment, though she was looking forward to interacting with our speaker. So I would like to take this opportunity to welcome our speaker for today, Professor Vincent Galicchio. A very warm welcome to you, sir.
Thank you. Glad to be here.
So before I hand over to sir, I would like to give a brief introduction. Dr. Vincent Galicchio has 47 years of experience in academic medicine and research, covering experimental hematology, immunology, and developmental therapeutics for human diseases such as AIDS and cancer. He has earned national and international recognition for his efforts. In a first-time study reporting an academic scholarly productivity in the Journal of Clinical Laboratory Science, Dr. Galicchio was rated the #1 academic biomedical laboratory science researcher in the United States. His passion for research, a high value placed on excellence, a strong reputation as an esteemed collaborator, and a tenacious desire to see a better therapy for human diseases brought to market speak to his overall character. Over the years, his direction leading a research team produced more than 250 peer-reviewed publications, 36 book chapters, several textbooks, countless numbers of invited presentations nationally and internationally, and 14 United States and 1 international patent. Many of his students are active researchers at many national and international institutions around the world, in addition to those that are active dentists, physicians, and other allied health professionals. Dr. Galicchio has secured in excess of $23 million in research funding from various public and private funding agencies, including several foundations and many pharmaceutical companies. As a board-certified medical laboratory scientist by the American Society of Clinical Pathology, Dr. Galicchio serves as a clinical laboratory director. He holds clinical laboratory directorship certification from the South Carolina Department of Health and Environmental Control. He has served as a consultant to many national and international agencies and companies related to various aspects of health promotion and safety. Dr. Galicchio earned his PhD in experimental hematology at New York University Medical Center and completed fellowships in hematology at the Sloan Kettering Institute for Cancer Research and in physiology at the University of Connecticut Health Center. He was awarded a diploma in internal medicine from Vasil Goldis, University of Arad Medical School, Romania. He served as president of Alpha Eta Honor Society, the International Society for Lithium Research, the International Federation of Biomedical Laboratory Science, and the vice president of the Educational and Research Centers in Trace Elements, operated under the auspice of UNESCO. He is a fellow of the Association of Clinical Scientists, the Association of School of Allied Health Professions, and the Royal Society of the Arts. In 2003, at the 200th anniversary, the Royal Society of Arts celebration, because of his long-standing accomplishments educating English biomedical laboratory science students, Professor Galicchio was recognized by Her Majesty Queen Elizabeth II at a ceremony at the Buckingham Palace. So, sir, I would like to hand over the stage to you now.
Thank you very much for that very kind introduction. First, let me say it's a great pleasure to have this opportunity to speak about a subject that has been of interest of mine for many, many years. So what I hope to be able to do today is tell you a story. Before I begin, I'd like to acknowledge and thank the invitation that I was extended by Professor Inare Banerjee, and I understand she's under the weather a little bit, not feeling well. I do wish her a very rapid recovery. Do miss her, and I hope she enjoys if she's able to listen to the presentation. Again, my thank you for her team for extending this invitation. Secondly, I think it would be remiss not acknowledging that indeed in India, as well as all across the world, we've been engaged in this COVID-19 pandemic, and we are hopeful that the conditions in India do improve, and we're very, very cognizant of the ill effects of the global pandemic. And so we do wish everyone a speedy recovery. So what I'd like to talk about today is the subject of lithium, and some may say, why lithium? And so I hope to be able to answer that question and relate to you the long history of lithium, and hopefully leave you with some ideas where lithium, even in this day in the treatment strategy, that we'll be able to talk about how lithium still should be considered as an additional medication, something I refer to as the alternate or non-psychiatric medical uses of lithium. So let's begin our journey talking about lithium. So next slide, please. Next slide. So why lithium? Well, we can all refer back, and we all know of the Big Bang, and that is actually where lithium began. Lithium, actually, go back a slide. Please go back. Yes, thank you. So why lithium? So life begins with lithium, as we're going to share with you today. So it has, as a metal, and it is an element. It's included and visible in the periodic table. So we have important properties that the element has that we're going to discuss, and then we're going to relate those properties to its use as a medicine in a variety of clinical conditions. So first, it's the smallest and lightest solid element. It has unusual clinical, pharmacological, biochemical properties that we'll discuss, and lead us to the discussion of why it still should be considered in terms of additional clinical conditions. It cannot be patented because it's a natural occurring element, although there are pharmacological ways that you can have patents created. In terms of its manufacturing, as we'll see shortly, it's very cheap to produce. And then in the chemical nature of what will be described, it actually exists as a salt. So there'll be some short discussion of inorganic chemistry in this discussion. Next slide, please. So if we review the background, lithium was discovered in Sweden in 1817 by August Arfwedson, who first identified the substance coming from a mineral source, and the original name was lithium. It was first isolated in appreciable quantities in 1855. So when we look at its utilization, we can now, and I think all appreciate, that as an element it has been, and we are all well aware of actually lithium in our lives because of this industrial non-medical association that the element has been applied to. So we know that it's been added as a lightweight addition to metal alloys. By doing so, it makes that substance harder or more durable. It is also added in the manufacture of glass. It's also a lubricant. It's added to grease. There is such a product called lithium grease, has been added or in the construction industry, in the manufacture of cement. And as I think we're all aware, it is one of the main sources in industrial use is its application in electrical batteries. So the computers that we're watching this particular session, our iPhones, or all of our cellular devices have really been made available in terms of what the power that's generated in the electrical battery is based on lithium. We're waiting the expansion of the electric cars that will become more readily available as they increase in production. and the availability of cars to have the opportunity to make electric vehicles is and will be based on lithium batteries. So lithium will still have its industrial base of support. What we're going to focus on is its utility in clinical medicine. So if we were to look at the amount or the percentage, only about 1% of the amount of lithium that's manufactured, mined. There's several different sources by which lithium is obtained, and that I think is going to be important. Okay. Hello, are we connected?
Yes, sir. You had got disconnected for a few seconds, but it's fine now. Hello? So can you hear me? So can you hear me? We apologize for this interruption, but I think Professor Galicia is having some problems with his connection. So can you hear me?
Hello, are we connected?
Yes, sir. So can you hear me?
Okay. I can't see the slides.
Oh, okay. I'll just a second. Can you see them now?
Yes, I can hear you.
Okay. So are the slides visible now?
No, I'm getting a message that there's an unstable internet connection.
Oh,
Uh,
yeah, your video is getting disconnected at times. Is it better now?
I see you, but I don't see any slides.
Oh,
I,
okay. Just a second. I'll just. Is it visible now?
no, still
Just a
nothing
second.
visible.
Okay, just a second. Payal, would you just share the screen once more? Stop sharing and share the screen once more.
Oh, there it is.
Okay, okay.
I can see it now. Okay. You can go to the next slide.
Payal, would it be, just a second, sir. There is a horrible time lag from what she's changing and by the time it's coming.
Okay, I can
Is it
see it
visible
now.
now, sir?
Yes, thank you. So I'll continue. Apologize for that interruption. So let's review the utility of lithium in clinical medicine from the historical perspective. It was first utilized related to rheumatic conditions in the mid-19th century for treatment of gout. Oops. All right, we're back connected with the slides. Next slide. Can we move to the next? Thank you. This slide is fine. So the utility of lithium was first recognized in treating clinical conditions associated with rheumatoid arthritis and also with gout. And gout is important, as we'll see momentarily. Let's first focus on the first utility as a psychopharmacological agent that is related now to its initiation clinical medicine, and that is in psychiatry. We owe a great debt of gratitude to the Australian psychiatrist John Cade, who is credited with the discovery of lithium in medicine, but in particular as a method of treatment for mental health disorders, in particular bipolar disorder. So while the slides are resetting, let me then give you the overview of the input that John Cade made in this area, and that he was a clinician, a psychiatrist, and treated patients with mental health disorders, in particular patients with bipolar disorder. He would be best categorized as a physician scientist, and he was convinced that although bipolar disorder, as it rightly is listed as a mental health abnormality, he was convinced that there was an etiological causation, in particular a biochemical explanation for the condition of bipolar disorder. So he devised an experimental methodology to try to test his hypothesis. And his hypothesis was that the mental health disorder, bipolar disorder, had an abnormal biochemical reaction. And so he made the connection that he thought that because several, if not the majority of his patients who had bipolar disorder also were experiencing the disease known as gout. Gout is a visual suffers from adverse effects based on the accumulation of uric acid. So uric acid builds up and is actually increased to the extent that it actually is excreted. So one can actually see under the microscope in urine specimens uric acid crystals. So he was convinced and thought that there was a direct relationship with the elevation in uric acid with the induction of bipolar disorder. So he decided to then test this hypothesis, and he chose an animal model. And the animal model he selected was the guinea pig. And the guinea pig is a rodent that is often kept by children as pets. It's a very cute little animal. When you put guinea pigs in a cage and they are then either approached or someone comes close to the cage, they will those animals in the cage will gather to the corner and they will start to shake, what's referred to as a startle reflex. And so he was aware of this phenomenon. Now, in his experimental methodology, he knew that he had to figure out a way to dissolve the uric acid crystals, because what he was basically going to do is he was going to inject into the guinea pigs the urine of his patients to see and measure behavioral changes. And so he went back to his inorganic chemistry, because he was initially unable to dissolve the uric acid crystals if he just mixed or diluted the uric acid containing urine with water, and realized that he needed then to have addition as a salt. And so when he first went through his methodologies, he added sodium chloride. Sodium chloride didn't work, potassium chloride. So he basically almost went down the periodic table. And finally, when adding lithium chloride to the urine containing uric acid crystals, lo and behold, the uric acid crystals dissolve. So now he had a method of dissolving the uric acid crystals. So now injecting in urine specimens, now either that had been treated or mixed with the lithium chloride or not, he found that this startle reflex that was readily as a behavioral characteristic of the guinea pig in the animals receiving any lithium containing preparation was not apparent. It didn't, the animals did not show this startle reflex. So he saw this as a behavioral change, which he viewed as quite significant. So then he took that observation and said, well, let's try lithium in his patients. And lo and behold, when administering lithium to his patients with bipolar disorder, the mania episodes and the highs and lows of characteristic of bipolar disorder were minimized, if not actually disappeared. And so it was viewed as a breakthrough for this particular clinical condition. It was written up in the Australian Journal of Psychiatry, published in 1949, excuse me. So this was the first clinical report of such an agent to be used to treat a clinical disease. Now, the good and bad of those observations were the following: that the results were so dramatic, meaning that administering the lithium in his patients basically eliminated the manic depressive episodes to the extent that the patients thought they were cured. And so upon making that erroneous calculation based on the fact that they weren't theoretically cured, they then stopped taking their lithium, and lo and behold, the symptoms returned. So that gave us pause to know that once a medical or pharmacological intervention for a particular clinical condition needs to be thoroughly studied, and just because there's an immediate positive effect, it doesn't mean that necessarily it's a cure, since this was a condition that showed that once the lithium was stopped, then the manic episodes returned. So concurrently, at the same time, another health issue was prominent, and that was the development of hypertension as it related to cardiovascular disease as a result of hypertension, in particular associated with the high levels of sodium. Sodium in our diets or as a food additive can contribute to the promotion of hypertension. And so in the United States, the Food and Drug Administration, which had approved lithium for the treatment of manic depressive bipolar disorder in the early 1970s, which was actually the very first drug ever approved by the FDA, there was talk, or there was at least the indication that perhaps lithium intervention to be a sodium salt substitute would minimize the degree or extent of the induction of hypertension. Unfortunately, because of the application, so if you, as all of us who apply sodium chloride as table salt to our foods, etc., we basically have it in the form of a shaker, and then you sprinkle it on your food. Well, that has no bearing on dosage or concentration. And so what happened in two specific cases where individuals who were then advised to substitute their sodium chloride as a table salt with lithium chloride then would just continually to shake as they would if it was sodium chloride. And in two cases, there was a toxic episode. And so this unfortunately caused an alarm, and the alarm to the extent that the FDA then banned lithium to be used as a cardiovascular agent in the case of hypertension because of this associated toxicity. So lithium as a clinical medication has what we call a narrow therapeutic index. And that's why, in terms of how it's prescribed and how it's monitored, blood measurements to indicate the systemic blood levels are important. So with this negative connotation of toxicity for lithium, then impaired its continued investigations in the realm of mental health disorders and psychiatry. So it was only after the really truly Herculean effort of the Danish psychiatrist Schou, and then followed up by a subsequent study conducted by Samuel Gerson at the University of Pittsburgh. They conclusively demonstrated the safety and efficacy of lithium in bipolar manic depressive illness, having conducted placebo-controlled double-blind studies. So lithium then became back into the pharmacopoeia for manic depressive illness. Next slide. Next slide, please. So lithium now in its utility in psychiatry has been proven to be both efficacious and other associated consequences of manic depressive bipolar disorder. And that is not just the associated depression, but also the unfortunate opportunity or the induction of suicide. So suicide as a consequence of depression is quite well minimize the not only the effects of the manic depressive illness, but also the associated issue of suicide. Those studies were conducted in Sweden. Swedish psychiatric community did a very investigative and thorough evaluation of the effects of lithium to minimize the suicide associated with bipolar disorder and depression. So that's another important clinical characteristic of lithium in terms of its mental health capacity. It's been estimated since the 1960s, well over 1 million patients worldwide have received lithium. And it's also important that it's had an impact on the healthcare costs in terms of lowering those healthcare expenditures related to mental health disorders. And the Institute of Medicine in the United States, which is an arm of the National Academy, did an investigative analysis of that and found that with the use of lithium in terms of the United States economy, it saved well in excess of now with a more later evaluation. So its economic impact has been quite demonstrable. Next slide, please. Next slide. So we're going to make a shift now in terms of these alternative non-psychiatric medical uses of lithium. And so there was an exhaustive series of studies conducted by many, what I will describe as lithium investigators, whether they were biochemists, physiologists, even plant physiologists, not just animal physiologists, as well as clinicians, scientists, psychiatrists, biochemists, nutritionists, Nicholas Birch, who spent many years at the University of Wolverhampton in the United Kingdom. Basically, we looked at the tissue distribution. In other words, when lithium is administered, whether it's in an experimental animal or a human, what's the tissue distribution profile? And this particular slide just shows that the largest peak that's measured there, which is quite demonstrable, is its presence in the blood and the bone, which is an important feature that we'll talk about in a little bit more detail. That is the effectiveness of why lithium is so widely distributed throughout the body. Next slide, please. Next slide. So this physiological effect of lithium now is what we'll begin to focus on. So lithium as, again, an element, part of the periodic table, it's present in all of our surroundings. That is, it's present in the soil, it's present in rocks, it's present in groundwater. And so everyone, depending on their, obviously their physical location in terms of the topography, the land, the amount of water drainage, whether they live close to rivers, lakes, streams, etc., will incorporate some degree and amount of lithium just in their normal daily existence. Most of it comes from it being acquired through either foods, that is in the fruits and vegetables in terms of where those crops are grown, as well as being present in drinking water. So this is going to be an important feature for discussion because of the widens and the natural occurring presence of lithium, whether it's in the groundwater or in the table rocks, and also in the ground in those areas from which agriculture and related to growing crops, from which we get our foods and foodstuffs. So there was a question in terms of what then is, or is there a major physiological role for lithium to play, much in terms or much analogous to several of the other monovalent cation, divalent cations that we know of that are well documented. So one would be, we know that iron, for example, is considered a trace element because iron is an important trace element or element in the fact that it combines within heme and hemoglobin, and it's actually when erythrocytes, red blood cells, as they circulate through the body, and we through respiration acquire oxygen. It's the oxygen molecule within hemoglobin that is necessary for delivery to organ cells and tissues to engage respiration. Well, the key feature there is that the oxygen molecule binds with iron, either ferrous or ferric forms, and that is the important link by which then iron is considered a trace element, because lack of iron then would have an impact in the ability of an individual having low iron stores or low iron deficiency, being able to deliver oxygen to tissues. Another is zinc. Zinc is important for growth in early lives, as well as helps promote a natural operating and effective immune system. So the same question was asked of lithium. Does lithium have a natural physiological role by which then it would be classified as a trace element? So through you can go to the next slide, by Manfred Anke, the University of Leipzig. And next slide, please. In Germany, conducted a very, very tedious and laborious set of experiments as he and his research team. Again, next slide, please. Yes, thank you. Manfred Anke has conducted over the period of time, he and his colleagues, a variety of experiments were actually to address this question. So he observed in a number of species, meaning birds, animals, for example, chickens, cows, sheep, and basically did the following evaluation. That is, he measured the amount of lithium consumed by those animals, whether it was in terms of their lithium content based on their food intake and their water intake, measured what the ground amount of lithium, and then changed or was able then to eliminate. So he basically had the evaluation of looking at those population species under the control ability of being able to have lithium in their diets versus a period of time where lithium was deficient, and did that by either cooking or other physical manipulations, basically then to remove as it indicates here, low lithium diet between 0.005 and 0.05 parts per million. So this was then classified as a lithium deficient. So he observed the populations, again, that were studied over several generations, usually at least second, third generation, and basically then looked at any physiological changes or abnormalities. And what he was able to demonstrate that in the populations that existed for several generations in this lithium poor diet, found that there was a decrease in fertility and inability then to conceive. And then also there was an increase in the rate of spontaneous abortion. So he and his colleagues concluded that there indeed was a physiological role for lithium, and that it is needed and it's important in the maintenance of fertility and sustaining newborns in utero over the course of the various length of time of gestation for those species. And so based on that evidence, and in part, lithium is considered a trace element for its role and function that it plays in fertility and gestational development. Next slide, please. Thank you. So now we're going to make a transitional shift. So we've described to you that lithium had a role to play in psychiatry, in particular in the treatment of manic depressive bipolar disorder. The way lithium is administered is that if an individual is to be considered to be put on lithium for treatment, the initial measurement is a blood sample is taken to determine background base level of lithium. Then lithium in the form of lithium carbonate is then prescribed, given 300 milligram tablets per day over the course then of 2 weeks. And then a subsequent repeat blood sample is taken, and that will determine the baseline lithium value for that particular interval. Now, therapeutic window is usually somewhere on the order between 0.5 and close to 1.0 millimolar per deciliter of blood. So that's the therapeutic window. So in the accumulation of data, or the accumulation of more patients diagnosed with manic depressive bipolar disorder, administered lithium, like or not unusual for many medications over time, since, as we alluded to back with the initial studies of John Cade, that if patients decided to stop taking their lithium, the benefit ceased and the episodes and clinical conditions returned. So it basically, as far as the recommendation, an individual prescribed lithium had to take lithium for the rest of their lives. Subsequent, as when medications are administered in that particular context, there often can be what are referred to as side effects, and that is other clinical manifestations or parameters that may change characterization by which the lithium is prescribed. So initially, we're talking about its utility in the psychiatric realm. Lo and behold, that in patients being monitored, again, they have to have their lithium values monitored over the course of the time that they are on lithium. An interesting observation was reported, and that was the elevation of the white blood cell count, in particular a cell known as the segmented neutrophils. And so individuals basically then on lithium over time would develop what we call leukocytosis. So leukocytosis is a common occurrence if we have an infection. It's one of the body's main ways to fight that infection. The production of white blood cells are increased, at least in terms of their measurable amount in peripheral blood. So this was a very interesting and highly suspect observation, and that is basically why would a monovalent cation drug as a utility and use in bipolar disorder have associated with it a hematological or a blood effect. So
We apologize for this interruption. It seems that there is a lot of network problem today. Just be patient, and I'm sure sir will be back in a few seconds.
Okay, I think we're back. I see the slide. So I was commenting on the fact that when I was a hematology fellow in the mid-1970s at the Sloan Kettering Institute in New York City, my project that was assigned to investigate was basically to address this question: why in bipolar patients, again, clinical psychiatric disorder, administered lithium, why then did they measure, or why did they then respond with the hematological condition of an elevated white blood cell count, in particular circulating neutrophils? And so that series of experiments were basically, we administered dose escalation like John Cade, but in this excessive series of experiments were conducted in mice. And basically what you see here is dose escalation, and we are using concentrations that were defined in the clinical literature. And then what we're measuring here is a cell known as the CFUS, which basically is the pluripotential hematopoietic stem cell. So for all of you non-hematologists out there, the pluripotential hematopoietic stem cell is a cell that gives rise to all the formed elements of the blood. Formed elements of the blood, we are referring then to erythrocytes, platelets, thrombocytes, neutrophils, lymphocytes, eosinophils, basophils, monocytes, all of the formed elements that constitute blood, all arise from a single cell known as the pluripotential hematopoietic stem cell. This was a series of studies and observations that were credited to physician scientists that basically made that discovery. So fermentations is what are this experimental system. And basically what we see here is a dose escalation in the number of pluripotential stem cells under the influence of lithium. And we can see a dose escalation, meaning that we have an increase when we look and measure, increase the lithium concentration, then the effectiveness to stimulate and show an increase in the stem cell number declines. So we published this work in the journal Blood in 1980. So this is the first reported case of lithium influencing the pluripotential hematopoietic stem cell population. Next slide, please. Next slide. So needless to say, this observations initiated a cascade of investigators around the world to look at and then further investigate this lithium blood cell or hematopoietic level of activity. So this in of itself can be a separate discussion or lecture, but basically to summarize, again, the initial studies that we conducted were done in animal models. Then the obvious question, well, what happens in humans? Are the pluripotential stem cells in humans, especially those patients taking lithium for a psychiatric disorder, what happens to the population of those stem cells in the human environment? And yes, now in the human environment, that cell is known as a CD34 positive. And so we can measure an increase in human-derived pluripotential hematopoietic stem cells, whether we would take samples of bone marrow and mix or incubate the cells with lithium and then do the analysis, or we can just take blood specimens from patients And we can also, at the same time, measure an increase in the pluripotential stem cells. So it wasn't just an animal or under experimental control set of conditions to see the increase induced by lithium or pluripotential hematopoietic stem cells. We could also measure it in a clinical situation. This led to additional thoughts and questions about taking advantage of this effectiveness of lithium in terms of its ability to increase not just pluripotential stem cells, but in addition, this observation of increasing white cell production. And again, as a side issue or a tangent in this context is that patients undergoing the myeloablative therapy, whether it's chemotherapy or radiation for cancer, unfortunately develop side effects or toxicity of that exposure to anti-cancer agents, therefore become either myelosuppressed neutropenia or thrombocytopenia, which in of itself are both adverse conditions. So the question then was, could we administer lithium to cancer patients who would be receiving chemotherapy and radiation, and by doing so would minimize the myelotoxicity and the thrombocytopenia. So the National Cancer Institute in the United States made funding available to address that experimental question or clinical question related to whether or not did lithium have a utility in cancer patients to minimize those adverse effects. And the answers were yes and yes. So lots of studies then were conducted in many laboratories around the world, which were focused now on lithium's ability to modulate cellular proliferation, in particular with a blood emphasis. But blood, since all of the cells have a known physiological feature, whether it's to protect against opportunistic infections like neutrophils or lymphocytes against viruses and other cells that have immune-based, lots of studies, and want to then point out the vast amount of individuals, physician scientists, dedicated researchers who conducted the vast amount of studies that have generated the information that basically leads us to further lithium, but to understand these basic lithium effects on the hematopoietic system, immune function, and a variety of other clinical activities that are important. Next slide. Next slide, please. So I'm just basically going to just proceed fairly quickly here, because there's been many studies, and I would just encourage anyone who's of interest is just to Google lithium in hematopoiesis or lithium in blood effects. And you can then go in and look at the many scientific articles, review articles that have been published. We basically published 2 books on this topic. And so just this slide and the next several slides basically just outline a number of known, since the ways by which blood cells can be influenced, both positively, meaning increasing their number of production, as well as also inhibiting, is a complicated interaction of cells, and also of a whole list of molecules that are defined as cytokines, interleukins, colony-stimulating factors, and hormones. And each of those factors then is going to have a specific physiological effect, whether it's immune-based, immune activation, immune suppression, etc., which is important. So here I list some of these observations. Next slide. Next slide, please. Again, focusing on a very important characteristic, and that is inflammation. Inflammation, by all measures of assessment, is a non-desired physiological response. So inflammation basically is a catalyst and contributes to the etiology of many clinical conditions. And so in general, goes without saying that if we can promote anti-inflammatory reactions, clinicians' clinical responses is and would be of benefit. So lithium is in that realm as well, in terms of its ability to inhibit molecules that can promote inflammation. And so that is what we would call an additive effect. Next slide. Next slide, please. Next slide. Thank you. And so the immune-based reactions, not just on cell-mediated immunity, but also humoral immunity, that is the ability of lithium to influence the production of antibodies, is also been demonstrated. As you can read here again, I refer to anyone who wanted more information. You just simply do a lithium Google search based on the particular topic: immunology, immune function, hematopoiesis, etc., stem cells. You'll see the plethora of literature that is in the respective field for these topics. Next slide. Next slide, please. May I have the next slide? Do we lose our connection? Next slide, please.
So do you want the slide on the effect of lithium on T cells or the NK cells?
So in addition, again, based on immune-based phenomenon, immune and influence on immunity can encompass many different areas, both in terms of synthesis and activation of a multitude of cytokines, interleukins, growth factors, but also activity of certain immune-based cells, one of which is natural killer cells. So there has been evidence that lithium could promote anti-tumor responses. Next slide, please. Next slide. Now, another tangent here, and that is the following. I apologize for the inability to sort of read this particular slide, but I'll basically describe it to you soon. It has two key points. So when you look back at history, many individuals throughout history have been diagnosed with manic depressive bipolar disorder. And that is individuals that we all know and are familiar with. For example, Vincent van Gogh, lots of, just documenting in historical perspective, and individuals that would be encompassing the arts and literature, humanities, so to speak. Ernest Hemingway, for example, Norman Mailer, another artist. What is well documented is the condition of manic depressive bipolar disorder, and the fact that there, as we indicated earlier, there was a high degree of suicide associated with these psychiatric disorders. And so another individual who subsequently passed away a few years ago, if anyone is familiar with the American actress Patty Duke, she received the Academy Award for her portrayal of Helen Keller. And so she was diagnosed with bipolar manic depressive illness. Subsequent to her diagnosis, found treatment to be extremely frustrating and exhaustive, to the point where she too came to the conclusion that her life and her quality of life was not worth it and was contemplating suicide. Luckily was able then to engage with a psychiatrist who advocated that she try lithium. So she tried lithium, and lithium then reversed her manic depressive bipolar disorders. And so based on her observations and her return to be able then to achieve a high quality of life, she wrote an autobiography. And in the autobiography, she mentions somewhat serendipitously, without, one could easily miss it, in terms of her description of what she experienced while being a lithium patient, is that she realized she very rarely ever catches a cold. Well, we know that what causes cold? Viruses. And then an examination, again, looking at the biochemical impact of lithium in terms of how it functions, and more importantly, its effectiveness in the context that we look at it and address it from the biochemical point of view, biochemical reactions oftentimes are catalyzed by substances known as enzymes. Well, enzymes, in order for their activation to be complete, in order to engage in the subsequent activation of that enzymatic reaction, needs a metal cofactor in order to initiate that enzymatic activity. More often than not, that metal cofactor seen in enzymology, if you will, is the divalent cation magnesium. Now, it was then based on comparison of stereoisometric analysis, so that the one compares the magnesium ion to the lithium ion. One then sees similar size, even though magnesium is a +2 charge, lithium is +1. So the analysis then basically came to the following conclusion, that at the enzymatic level, when an enzyme reaction, when an enzyme is looking for or needs magnesium to essentially serve as a metal cofactor, if it sees lithium first, lithium then is able to bind in the binding site of the enzymatic reaction. So oftentimes that incorporation of lithium versus magnesium has a different biochemical effect, usually the opposite action if it was engaging magnesium. And so this asks the question, would lithium then be at all efficacious in terms of viral infections, since viruses require biochemistry to succeed and survive biochemical reactions in terms of DNA polymerase, RNA polymerase, reverse transcriptase enzymes that require magnesium as the essential metal cofactor. The question then is, what would happen if lithium was used? And so in a series of studies conducted in vitro and in animal models, and what we see here are two graphs. The top one is studies conducted in an animal model of immune deficiency meaning a decrease in the number of, again, peripheral blood derived cells. On the top is the two lines. We're measuring the number of lymphocytes, and in the bottom figure, we're measuring the number of neutrophils present in circulation. So you can see that the top line in each of the figure is the control, that is is the effect of lithium without the virus. In the bottom panel, when it returns, is the effect, is the bottom line, that is the decrease. Top is lymphocytes, bottom is neutrophils, is what happens under controlled conditions and under the influence of this RNA virus in an animal model in the absence of lithium. In the top line for each graph, the top again is lymphocytes and the bottom is leukocytes. One sees a lithium effect. So lithium was able to reverse, in this context, the lymphopenia and the neutropenia associated with an immune deficiency related effect. And again, with all of the biochemical and pharmacological as well as physiological actions of lithium, this is multifactorial, but one of which, at least in terms of inhibiting viral replication, is been hypothesized due to the fact that lithium effectively competes for magnesium in the catalytic binding site. So next slide, please. Next slide. You can see the reference for that journal article in antiviral research. Next slide. Thank you. So again, this is an overview, and what we see here is what we call the hematopoietic tree, or the tree of hematopoiesis. So the very top cell is the pluripotential hematopoietic stem cell, and then we see depicted are all of the linear lines of development, whether it's the erythroid line, the myeloid line, whether it's segmented neutrophils, basophils, eosinophils, monocytes, and then on the far right, we see the immune based, whether it's B cells that make antibodies or T cells that are involved in cell-mediated immunity. So lithium interacts at many of these steps, especially in the production. So whether it was, again, measured in animals after treatment or in patients, it shows a positive effect to increase stimulation in both number and activity. Next slide, please. Next slide. So again, this just summarizes, again, blood effects. So lithium can influence the number and proliferation of cells that give rise to the cellular increase in neutrophils seen in patients with bipolar disorder on being treated with lithium, as well as other aspects of immune hematopoiesis. Next slide. Again, this is a complicated slide, but basically it's to give you the complexity that shows that the action of lithium on blood cells, in addition to actually increasing their proliferation or changing in their rate of proliferation, also can have an amplitory effect on, again, as I mentioned, the activity of interleukins, cytokines, growth factors, and hormones. So this just gives you an overview. If you're interested, again, just advise you to perform a little research, as many of these topics have been thoroughly addressed in the scientific literature regarding concise reports, et cetera, that reviews the overall effect on. This is, in addition to a direct action on cellular proliferation, there's also important activities, as depicted in the slide, that act on a multiple set of factors, in particular GM-CSF, MCSF, GCSF, and a number and cascade of cytokines. So complex set of interactions that help explain why we see the physiological effects that are attributed to lithium. Next slide. Next slide, please. Next slide. And knowing that lithium is a monovalent cation, not just that it has the capacity to enter cells, we know that it can also, once inside a cell, it can actually then traverse and be potentially of influencing nature on the nucleus. And so there are a number of signal transduction mechanisms and neurotransmitter receptor that have been studied. Again, basically to, number one, understand the physiological and pharmacological nature by which it influences mood disorders like manic-depressive bipolar disorder, but also these other physiological as you'll see, these non-psychiatric medical uses of lithium in terms of the overall effectiveness of lithium based on these cellular systems. And so this is just a sequential showing the number of different pathways within the nucleus by which lithium can influence single transduction mechanisms. Next slide, please. Next slide. And so a number of different cellular systems have been studied to try to elucidate the effectiveness that lithium will have on modulating psychiatric clinical conditions as seen in psychiatry. And so a number of different pathways and molecules have been identified to be under the influence of lithium. And so this slide just shows the particular components of the inositol pathway that is often been predicated as an explanation for the manic depressive reversal of effectiveness seen with lithium. Next slide, please. Thank you. So these, again, are important intracellular signals and important molecules that have been thoroughly investigated. Want to point out one in particular, and that's highlighted in italics, and that is the enzyme glycogen synthase kinase 3 beta. Lithium is the most potent inhibitor of this particular enzyme. This is an important physiological or pharmacological activity because glycogen synthase kinase, or GSK3 beta as it's known, is implicated in a number of additional mental health disorders that we'll discuss momentarily. And so that is a key step in elucidating lithium's effectiveness for a number of different mental associated activities, basically under the heading of dementia and other disorders. So that gives us now a reason to believe that lithium possibly could be of utility in diseases such as Alzheimer's disease, but I'll go into that a little bit more detail shortly. The other is it influences molecules that have an effect on apoptosis, either to slow down the process or control apoptosis, in particular BCL2. So next slide, please. So we're going to talk about now this effectiveness on GSK3 beta. GSK3 beta is an enzyme present in neural tissue, in particular in the hippocampus, and it has a physiological action on phosphorylating the protein tau. One of the consequences of development of Alzheimer's disease is the increased presence of tau protein, causing an accumulation, which then builds up and forms plaques that inhibit the neurofibril or cause what's seen anatomically on neurofibril tangles. And so the question then became, is there a way then to regulate GSK3 beta activity? Because it was shown that in cases such as Alzheimer's, in the production of tau protein that would contribute to the formation of these neurofibril tangles, the enzyme was overactivated. Therefore, the phosphorylation of the protein was increased. So there was a greater amount of tau protein being hyperphosphorylated, meaning available for accumulation and forming these neurofibril tangles. So the question then was experimentally addressed. And so the need to look at this in the perspective of the following is that stress can come in many sizes, shapes, formats. Stress is a mechanism, or is an inducing agent for promoting hyperphosphorylation catalyzed by tau protein. And this is all correlated with an increase in activity of GSK3 beta. Going back now to this explanation in terms of biochemical effects in relation to the enzymes and the effectiveness in terms of inhibiting magnesium divalent catalytic action that GSK3 beta relies on by magnesium, then what would happen if the conditions was now seeing lithium rather than magnesium? So subsequent elegant studies to address that question is that what effect would lithium have on GSK3 beta activity? And it has been now well documented that lithium is the most potent inhibitor of GSK3 beta activity. So then how would the effectiveness of lithium to inhibit GSK3 beta in part have on tau hyperphosphorylation? So conducted by Schou in the lab years ago, basically tried to address this question. So next slide, please. And so we basically then conducted a series of experiments where using an experimental animal model system that were genetically bred to increase tau phosphorylation, and we would be transgenic mice then being able to demonstrate the hyperphosphorylation of human tau in the experimental model, was basically then subjected to the following treatment strategy. And that is, after the mice, in this case, the animal model system, they were subjected to starvation, meaning they were deprived of food for 72 hours. That in the animal model system was effective enough to induce a stressful situation, which was correlated with an increase in GSK activity and tau hyperphosphorylation, or tau protein. So the following studies were set up, and that is, we examined without starvation instead, and in control on lithium. Again, we use sodium chloride, and then so with and without sodium and or lithium, we then looked and monitored the levels of tau phosphorylation. So next slide, please. And here's the results of these studies. So in this experimental model system, we then compared also young animals versus aged animals. And so that's an important factor because of the additional criteria. Does age have an effect on inducing hyperphosphorylation, or the sensitivity of hyperphosphorylation? So measured levels in the hippocampus, see in terms of the results here. This is the results when young mice that were 8 weeks of age were studied. We can see that without starvation, in the presence or absence of lithium, basically no statistical significance. However, on the dramatically elevated level in the GSK activity. And then upon subsequent treatment with lithium, we see that increase in GSK3 beta activity was markedly depressed. Next slide. The next slide will show the same experimental conditions now performed in aged mice that were in the age of a mouse were a year old. And we see the same overall effect. That is, in the absence of starvation, no real resulting effective significant change in GSK levels.
We apologize, but I think Sir has gotten disconnected. I'm sure he'll be back. Just be patient here. He's back.
As a result of starvation. Again, starvation by definition was depriving the animals of a food supply for 72 hours. So we can see clear cut whether the animals were young or they were aged. Lithium still had the effectiveness to minimize and reduce the elevation in GSK3 beta activity that was seen following starvation. Next slide, please. And here we're just looking at the measurement and the depiction of the protein. That is we can see here elevation. Here's the 8 weeks, and we can see the numbers characterize the groups. We can see then elevation in the tau protein in the starved without lithium. And then in the animals treated with lithium after starvation, the protein is virtually back to control levels. And at 12 months, we see a very high, strong Western analysis show the presence of the protein following starvation, and then following lithium, a significant inhibition. Next slide, please. And the important characterization here is that when we're administering lithium, we then want to ask the question, well, what were the systemic blood levels as it relates then to the effect of this scene? Because as we indicated when we started this discussion and talked about the results that were seen initially with respect to toxicity, can we, or basically ask the question, can we see these pharmacological effects on these different levels of molecules, tau protein, et cetera, enzymatic activity at concentrations that correlate with the clinical utility seen in psychiatry? And the answer to that is we can see right in terms of the levels of a concentration. We can see that the lithium levels are basically important to be able then to retrieve clinically to have this effect on tau phosphorylation and GSK3 beta activity. Okay, just waiting for the slides to return.
Can you see the slides, sir? Sir, are the slides visible? Sir, are the slides visible?
Not yet. Yes, they are. Thank you. So as an overview now with the observation that lithium has in terms of its effect on mental health and other abnormalities that are associated with neurological disorders, we see here a list of conditions that lithium has been postulated as potentially be of therapeutic importance or therapeutic utility. And that is stroke, Huntington's disease, Alzheimer's, Parkinson, renal degeneration, spinal cord injury in particular, which has to do with its effect on stem cells, as well as HIV-induced dementia. Next slide, please. And so studies have been performed and looked at this particular correlation. Would lithium be efficacious in the context of Alzheimer's? So I won't review in great detail, just to again point out that based on the fact that lithium has a significant effectiveness on inhibiting the enzyme associated with the activation of tau hyperphosphorylation, it could be conceived that lithium should be tested in its ability to have an impact on the incidence and development and subsequent treatment for Alzheimer's disease. Next slide. Next slide. Associated also is the opportunity that lithium could provide protection based on a number of its biochemical effects related here in the context of neuroprotection, because it has the capacity to influence processes that are associated with apoptosis, which is programmed cell death. There's opportunities to investigate lithium in clinical conditions that have dysregulation related to life cycle or apoptotic mechanisms, whether it's through BCL2 and or P53 and or BAX, which are molecules that are effective in the apoptotic regulatory mechanism. Next slide, please. Next slide. Yes, moving on. Now, an exciting area that has come to the forefront in the past several years is the ability of lithium, taking into account its effective ability to influence stem cells and stem cell proliferation, that we documented for the first time, or made the discovery back when I was a fellow, and reported for the first time that lithium had effect on stimulating the proliferation of blood-derived pluripotential hematopoietic stem cells. Subsequent to that report, lots of investigators, a lot of scientists around the world have been investigating and taking into account the ability of lithium to influence stem cells and stem cell proliferation. An exciting area of research and clinical utility that has become prevalent in the past several years has to do with the relationship between lithium as an effective intervention for spinal cord injury, in particular blunt force trauma, where based on whether an accident of some intervention that causes spinal cord tissue destruction and subsequent paralysis, basically the question then, could the abnormal adverse effect of tissue destruction, neural tissue destruction, with the consequence of paralysis, be anywhere or any way influenced by lithium to induce the regeneration of that neural tissue, focusing on the ability of lithium to stimulate neural stem cell replication. So studies conducted over the past several years by Professor Yang and Weiss Young, who's at medical school in New Jersey, have conducted basic studies and also clinical trials investigating the ability of lithium to reverse the adverse consequences of spinal cord injury. And so a number of studies have shown that lithium, when applied based on its activity to produce and increase the population of stem cells, actually can stimulate the reformation of neural-based stem cells. And so the level of paralysis can be minimized and some degree of normal function returning after the utility of lithium. So there's been a great area of interest in this particular realm, which gives us great hope for individuals who would have a very, very, very poor prognosis based on the paralysis following spinal cord disease, that if lithium can be either injected or applied at the time of neurological-based stem cells, there can be an acceleration in the repair and the regeneration of nervous tissue, which is an exciting area of further study and further research. Next slide, please. Next slide. So again, there have been a number of clinical trials, both performed in the United States, but many of them have been performed in China because of the vast number of spinal cord cases. And so there are a number of reports in the literature where lithium has been shown to be effective, both minimizing the pain of the spinal cord blunt force trauma, as well as minimizing the paralysis and actually increasing the rate of recovery. Next slide, please. Next slide. Thank you. So in summary, lithium has been used in a wide variety of clinical disorders, starting with its well-documented efficacy in treating patients with bipolar manic depressive illness. Because of its effectiveness in stimulating a number of different populations of cells, starting with and importantly stem cells, then the application then of lithium to utilize those effectiveness to take those effectiveness of those procedures and apply them to different clinical situations is ever an important area of research. And I'll leave you with one last sort of point in that regard, is that all of us, no matter where we are located, no matter what our lifestyles or conditions, et cetera, is that we all age. Okay, aging is a physiological function that has one of its key components is that not as a consequence of us aging as a population, as individuals, over the course of time, our indigenous and endogenous production of stem cells decline. So as we age, we have far fewer stem cells than when we were born, or certainly during our early years of development. So as seen with the aging experiments, is that could we then restore our stem cell youth or stem cell effectiveness, because the number of stem cells drops off dramatically as a function of age. And so consequent in giving us the entire new clinical arena of regenerative medicine, could we then enhance recoveries and rates of deterioration, basically as our body parts wear out as a function of age, which is contingent on this decrease in stem cells? Could we then actually have a substance like lithium that actually can now minimize the decrease of stem cells over time, be able to at least first and foremost diminish the rate of decline of stem cells over that period of time, but more importantly, perhaps even increase or at least maintain a level of stem cellness so that our rates of aging and deterioration as the function of regenerative medicine now is so important. So this, I think, is a very, very intriguing opportunity that perhaps we as individuals can actually do something in order to help maintain our indigenous population of stem cells so that they don't deteriorate over time. And that would leave with the advices that I think we all can benefit by having a little bit of lithium either to our diets or introduce itself as an effective agent, and perhaps we would be better off, or at least we would be able to then slow the aging process and at least enhance some of these regenerative properties that are been attributed to lithium. So I will conclude. I want to thank again the organizers for allowing me the opportunity to speak today. I apologize for the intermittent interruptions. Again, I apologize for the intermittent interruptions with the internet connection. And so I do hope the audience has found the presentation satisfactory. If anyone would like to ask me a specific question, certainly we can make my email contact available, and I'd be more than happy and pleased to personally address any question offline. So I believe we're at the very last slide. So if you can go to the next slide, which should be the last slide. Next slide. Again, these slides just summarize what we've been focusing on over the course of the presentation today. Next slide. Again, next slide. And next slide. So I want to thank you again for your attention. Thank you.
Thank you so much, sir, for this wonderful lecture. We have a few questions that the audience has put forward in the chat box. So if you have time, we can address them now. So should I put the questions forward?
So where are they located?
Yeah, I'm showing them. So the first question is,
Oh,
what
okay.
is the average list of lithium intake to maintain the body health and fitness?
Want to thank for this question. It's very important. There's been studies to demonstrate that there needs to be a certain parts per million of lithium as part of our daily lives in terms of consumption, et cetera. And so the U.S. Department and the FDA has listed somewhere in the order of, I would have to go back and just double check and make sure that it was in the presentation earlier, and the parts per million that's required. The difficulty is because of the heterogeneity of knowing where an individual is located based on the fact, as I pointed out, the maintenance is necessary for what appears to be normal physiological related to reproduction, et cetera. So the opportunity then to be able then to identify what is the necessary requirement, it can fluctuate based on what an individual actually consumes and actually drinks, but it's in the parts per million range, and I can get that information more precisely to anyone else who needs to know that information. Part of the studies that were conducted to demonstrate physiological activation was the need then to eliminate lithium from the diets of those animal species where it was studied. And so parts per million is what is usually required as a daily maintenance in order to promote normal physiological aspects of development. Thank you for the question.
Okay. So the next question is, why does the lithium level is not low in the adrenal and the pituitary gland, which are seen in the experiments over the 3 generations?
Yes, this has to do with tissue accumulation. So as I pointed out in the studies conducted with my collaborator, Professor Birch, a number of tissues, as well as the blood, can accumulate lithium, and so can make it available over the course of time. And so the fact that there is tissue incorporation as well as binding of lithium to tissues will allow lithium to be maintained in various organs and tissues. Again, it can correlate with the major question that was just asked, and that is, what is the accumulation based on food, diet, water intake, et cetera, which then can fluctuate. And so over the course of several generations, the fact that there wasn't an associated in the tissue accumulate in the material lithium is stored there but is not made then physiological available for use. Thank you for that question.
So he has another question, is that can lithium be used as a pain reliever?
Very interesting question. When lithium is looked at as a pain reliever, there have been studies, especially with the neurological studies, that there seemed to be a causation that pain relief was also an additive effect. That lithium, in terms of a pain reliever, gets us into this arena of optimal therapeutic concentrations. The major drawback for lithium is the fact that it has a narrow therapeutic window. So this goes back to the utilization when lithium was thought to be an effective substitute for sodium chloride to treat hypertension. Just one to indiscriminately utilize lithium in the form of, let's say, a tablet, and whenever you would have a pain, you would have to be cognizant of the amount of lithium and also what the systemic blood level would be, because one of the adverse effects, if the threshold is achieved and we get into a toxic area, is toxicity to the kidney. Now, clinically, this isn't an issue as it once was, because lithium can be more effectively monitored. We can do patient bedside, and we have also slow release tablets. So the pharmacological effects of avoiding sharp peaks in lithium concentration based on the delivery mechanism can be made more moderate or made more control. As a general pain reliever, to be used indiscriminately probably would not be an adequate substitute in that regard, but it would be something that I think would be very interesting to investigate. The question there would be how would it be administered as a pain medication versus what would already be made available that would have a lesser effect of toxicity. But it's a very good question, and something that, matter of fact, I'm going to do some research to see if this question actually hasn't been addressed. So I appreciate the question calling it to my attention. Thank you.
Okay, so I think you have answered a bit of the next question is how can we mitigate the concerning side effects of lithium like lithium toxicity, kidney damage, and hypothyroidism?
Yes, this is a very important question because this basically addresses the limitations that we currently have with a greater or more widespread use of lithium. So again, not to be redundant in my response, but the way this has been handled clinically in terms of minimizing toxicity across the board would be to better and more effective patient monitoring, and that can be done either in a clinic or inpatient with bedside monitoring, point of care testing, better methodological assessments to be able to measure lithium, better formulations, both in terms of slow release medications and then other types of lithium formulations that can be made available. So to be truthful and to be on record, I take 120 milligrams of lithium per day, and that is well below the therapeutic regimen that is recommended for psychiatry. Psychiatry is or the psychiatric effects as it related to bipolar disorder are much higher. They're well and surpassing somewhere between 300 milligrams per day, depending on the initial measurement following a dose escalation over the first 2 weeks, where individuals will consume up to 900 milligrams per day to establish baseline. Baseline then is important because that takes into account what exogenous sources you may have been exposed, whether it's again through diet, foodstuff, through fluids. And so this, what's highlighted in this particular question is very important. And this would be what limits more widespread use, but I believe we have more effective ways to manage and minimize any potential lithium toxicity.
Okay, so another question.
Thank you for
how
that
can
question.
we ensure lithium intake in normal conditions?
Well, in the form of lithium citrate, it's readily available. Most food nutritional supply stores or from nutritional aspects of being made available. Lithium is and can be obtained. My rationale is to prescribe, or at least with respect to my personal intake of lithium, is I'm hoping that it is boosting or maintaining the viability of my stem cells and my stem cell population. So whether or not it's doing anything to minimize any aging, I guess that's in the eyes of the beholder. But in terms of physiology, in terms of the ability to maintain, certainly the blood effects are particularly important. Again, to point out whether or not, in terms of the observations and studies correlating lithium having an antiviral effect, I think are very, very important, especially in this day and age with viral infections, not excluding even COVID, especially in the case of the major implication for COVID is this inflammatory response and cytokine storm, that some of the inflammatory cytokines perhaps could be mitigated or at least minimized in their detrimental effect on respiratory and respiration and other activities if one had exposure to perhaps a low dose lithium. We're certainly going to proceed that from a research angle. As I was sharing my last conversation with Professor Banerjee, when she told me that she felt that she was going to test positive for COVID, I pointed out to her that I had just submitted a research grant application the day before to address this particular question in terms of antiviral activity, but importantly, to minimize this cytokine storm. So under normal conditions, again, I proceed with taking daily lithium. I've been doing it now for years. I haven't seen any overall adverse effect in my condition, and hopefully my stem cells are enjoying the fact that they receive a little lithium every day, and I think that would be something important to consider. Thank you for that question.
Okay, so another question is, can you explain the role of lithium metal in heterogeneous catalyst development?
Explain the role of lithium metal in heterogeneous catalyst development. This is unfortunately beyond my level of expertise in the consequence of the biochemical aspect. Again, it appears that at least what's been hypothesized in terms of its involvement in enzymatic interactions is its ability to be effective substitute for magnesium. So the enzymatic catalytic site for binding of magnesium, it appears the lithium ion stereochemistry is about approximately the same size, irrespective of the charge. And so it basically is a simple competitive sequence. It's a competitive advantage. If the enzymatic catalytic site sees lithium before it sees magnesium, then the binding site will bind, or lithium competes effectively for binding versus magnesium. That may not be a complete answer to your question, but at least in terms of the biochemical effect to explain some of the enzymatic reactions, that's what's been hypothesized, that it's an effective competitor for the binding site, metal binding site between itself and magnesium. Thank you for that question.
Okay, so I think this will be the last question. Lithium is the same group as sodium and potassium. So do they work in activating gated channels as
well? I guess the question is basically asking whether or not there's a competition. We've done studies where we would manipulate and look at ways by which could we control the action of lithium if we then modulate the pathway channels, in particular sodium potassium. And so we using agents that block sodium potassium ATPase, using either agents that diminish sodium transport and activate or promote potassium, and vice versa. It was demonstrated that based on those analysis performed in vitro, again using bone marrow cells, that lithium was using sodium channels. So if you block sodium potassium ATPase, then you, not sure if that specifically addresses the question, but and you could use substances that we use were wabane and also amphotericin to look in comparison to see whether or not could we alter lithium's effect if we then exposed agents that had an impact on the transport capability. And so the question that we asked, the answer was yes. So I thank you for that question.
Thank you so much, sir, for this wonderful lecture, and it was great having you here. So I'm sorry that Professor
I
Banerjee
want to
could
thank
not
you for
join
all
us
your help.
today.
Yes,
It was my
please
pleasure,
pass
sir.
on my very best wishes to her. And
Yes,
again,
I will.
apologize for the interruption with the internet, but I do hope that
It's not a problem. It's
the
out of our
audience
hands.
enjoyed it. Okay, yes. I hope the audience enjoyed the time well spent today. I thank you.
Yeah, I'm sure. Thank you so much, sir. And thank you to the audience for joining us. And join us again on the 15th of May for a special lecture by Dr. Kalyan Rudra, Chairman of the West Bengal Pollution Control Board. And please subscribe to our YouTube channel. Our previous talks are all archived there and you can check them out later. You can also visit our website www.zoologyhub.org. Thank you again for joining us. Stay home, stay safe, take care, and see you again.